Yes, hi everybody. Today's talk is called SQL for Accountants 2.0 and Understanding the Beast via Spreadsheets. How many of you were at Ovid's talk yesterday? Yeah, excellent. Perfect. He mentioned something about spreadsheets, right? And well, forget about Excel when you talk about database and stuff like this. So a little bit about myself. I have been the DBIc tool chain, so not just DBIc, but pretty much everything relates to it. It's entire dependency chain and stuff like that. I have been the maintainer of this for about like 5 years now. And you can find me at ribasushi on irc.org, DBIx class, and on my email. And actually, how many here are Bulgarian in this room? I was hoping that I would be at a conference where most people in the room know what my name actually means. Because for everybody else, it's ribasushi. It's not. It's ribasushi. But anyway. So, as it says here, I clearly suck at slides because, Ovid talked about not talking about database and Excel at the same time. Well, I'm not only going to do that. I'm actually going to present from Excel. How cool is that? Right. So, sorry? It will get cooler than that. All right, so SQL, structured query language. It's very old. It's like 45 years old by now. And, old is hipster speak for something that's very useful and, and it just works. And it is obviously being, that old, it is completely standardized. And every single database speaks the same set of, dialects and stuff like that. Not the quotes, obviously. It is, I would say, hateful in a sense because on one hand it's very expressive, on the other hand it's kind of unwieldy. But at the same time it's extremely powerful. And what I want to take you through in this talk is not that much about, obviously we're going to talk about like basic syntax and stuff like this, but most of it is designed to show you how the database actually thinks about the data it sees when you ask it something. So the first 10 minutes will be very boring for people who know SQL. I'm sorry, but for people who don't, we have to get through this, and the rest will get much better. So disclaimer for anyone who doesn't do stuff professionally with SQL, I mean. Okay, so we're all good? Right. Moving on. So first of all, we are going to actually use one table, database table throughout the entire talk. And what the hell is this? Get away. Sorry about that. Let me just kill it for good. Okay, this will not happen again. So. That was fine. There we go. Mic kill again. Damn it. The cat dropped the mic. How is that? Yeah. There we go. Better? Can you hear me still? Okay. So we're going to use one table only with 3 fields. So we're going to have basically a company with an employee name, a department where they work, and their experience as an integer, like number of years or their like brownie points, whatever it is. Again, this is denormalized data. This is not stuff you're supposed to do. You read the disclaimer already. In general, in any database, when you create a table, you can actually get back to how it was created. An existing table, you can always see it with show create table, the name of the table, you will get this very same statement. So if you are finding yourself in a place with just, SQL console and nothing else, that's a good thing to know. So in this table, we'll have some sample example data, also called a fixture. We have 3 Java programmers with the corresponding experience. We have, we have 4 Java programmers, I'm sorry. We have 2 .NET programmers, and obviously we have 2 Perl people. Right, so first thing I'm going to show you, very simple. There are 4 operations you can do with data in a database table, in a relational database table. You can insert, you can update, you can delete, and obviously you can select. First, we're going to talk very briefly about insert. This is how you add things to your database. So you say insert into where, which columns you're putting values into, and the values themselves. So this, when executed, will basically add you another Perl rookie being hired, with 0 experience and so on. Before moving further, I need to explain how conditions are expressed in SQL. Conditions are basically when we say, make sure that this value is that much, or that value isn't equal to something, or it's greater than it, or it's less than it, and so on and so forth. Simple building blocks, just like in any programming language, we have simple comparison, we have logical combinations, and or not, and we basically can do stuff like this. Those are just simple examples to get us through the rest of the talk. For example, this will make sure that the employee column is Java boss, or the employee name is like any kind of boss, ends in boss, or there are two conditions, all bosses that are not Java developers, and not bosses who are not Java developers or are more than 5 years or 5 points experience. So really simple stuff. Right, so delete. The next operator, again, you need to say where you're deleting from, and normally you want to say what you're deleting to. This is weird. Let me try this instead. How about that? Does it hear me? Yep. Okay. All right. No more cats. Right, so when you delete from your table, you generally do not want to delete the entire thing. So you want to say that we're just going to delete some stuff. In this case, we're going to fire everybody that's less than 2 brownie points in. So what this is going to do is the condition is going to evaluate on the entire experience column, on all the data in it. It will select this and this row, and then they will be purged from your table. So the result will be this. Moving on, update. Again, very simple. You say what you're updating, you say what you're setting particular columns to, and again, there is a condition. So obviously, we need to be original and stuff, so our boss doesn't want to be a boss anymore, he wants to be a lord. And again, the condition evaluates, it selects the entire row, it updates only the column employee, and it is the result. Now we have a Perl lord and a Perl guru. Right, so also we can not only set particular values to a column, but we can use the previous value of the column as a part of an expression, just like you would have my a equals a plus 1. And this will work, and this particular expression will be evaluated for every row in your table the same, like separately at the same time. And the result of this query will be, it will match obviously everything, it will update only experience, and the experience will increase by 1. So far, really simple stuff, nothing to really talk about. And now we're going to get into what this talk is really about, how to pull data out of your database. Now, why is this talk understanding SQL through spreadsheets? Because in essence, your database holds two-dimensional data. You have columns and you have rows. Yes, there are obviously like XML stores, JSON stores. There are hierarchical databases. There are object databases, things like this. But this is not what people normally encounter. Normally, people store data in a two-dimensional CSV kind of like way. It's almost like storing a spreadsheet in a database. And moreover, when you talk to a database, what you get back is, again, two-dimensional data. You always get a set of columns fixed and some amount of rows. So selection. The simplest syntax for it is we want to get something from somewhere. And those are variables for a reason. We'll see a little bit later why. So, for instance, the simplest thing we can do is we can select everything. The star means the same thing like it used to mean in the good old DOS days. It means every single column that you have from a source, which is a table in this case, and it is company. It will give us exactly what we left in it. So the 3 Java programmers, 2 .NET programmers, and the 2 Perl programmers. Now, we can limit our selection. We can select only stuff that we want. So we can say that we want this column and this column, and we do not really care which department they come from. That's perfectly reasonable. In addition to the comparison functions, there are some what we call them aggregate functions. So basically, when applied to a column or really to any set of values, it will either count their amount or it will take their average, minimum, maximum. Again, simple stuff, but it will be very useful in a little bit when we get into some crazy shit. So for instance, just as an example, we can do this to our company table. And because our most experienced guy is obviously the Perl guru, we will get this result back. And now note that the data set returned to you will actually have a name for this column that never existed. There is no such thing as max experience, right? And when you don't tell the driver what to name it, it will just take, in pretty much all engines, it will take the stuff that you asked for and it will just snap it on top of your return that you can see in the case of Perl. You can see it with DBI STH names. I think it was the accessor. Now, we can change this by aliasing the column. We can give a name to any expression. So what we did there, we again selected the maximum experience, but this time we gave it a name, maxx, and this is what we're going to get back. Again, simple stuff. So far, any questions from anybody? We're good. Okay. Moving on. Now, the select has a couple of additional modifiers that we can use. The first one that I'm going to talk about is group by. Now, I'm covering it because we have to get some of the concepts down, but actually, in most databases, group by is something that you want to try to avoid. It is mostly expensive. Again, we'll see in about 10 slides down why it becomes expensive. But its basic syntax is, again, we have our first part, select what from where, and then at the end, we say group by a criteria. And what I mean by criteria, for example, we can ask this, which will get all the departments from our table, and then it will, if you imagine how you would write every single department out from your data set, all 11 of them, and then you would squeeze them down into all the unique values we have, which in this case are Java, .NET, and Perl. This is what the group by department did. Now, of course, we can write something like this. We can select the departments, and we can select more stuff from the company, and we can group by one of these columns. And on most databases, unfortunately, this will work. Now, this has a problem. Does anyone know what the problem with this expression is? Yeah, most of you do. OK. For those who don't, consider this. This is our data. So what we did here is we said, get me department experience. So we're getting these two things. And then we say, group them by department. So these three, fold them together. These two, fold them together. These two, fold them together. And also return me the experience. Now, out of these three, which experience are we going to get back? We didn't specify. What are we going to get back here? We didn't specify, neither here. Now, in SQLite and in MySQL without strict mode, you will get, surprise, you'll get something. You will get one of these values. There will be no average, no nothing. You will literally get the first value that happened to be in the table at the time. On Postgres, on Oracle, on Microsoft SQL Server, the database will say, I can do that. You know, you have to tell me what you actually want from those. Now, in this case, actually, what do we want? We want department, but we want to group by department, and then we want the experience. Obviously, we want some specific experience, so we can ask for it. For example, we want the most experienced person in every department. So we can apply our aggregate function. And the good thing about aggregate functions is that the group by will take them into consideration. So when it takes these three, it will see, okay, I want the max experience. So out of those, I'll give you this. Out of those, I'll give you this. And out of those, I'll give you this. And the end result will be this, which is much more useful.
Without the employee.
Without the, yes, without the employee. That's a good catch. Damn it. I should fix that. Thank you. We will come back to group by in like a minute or so. Order. Now, we obviously have rows in a database, and we would like to get them out. It would seem that we would get them out the same way that we put them in, but this is actually not the case. In pretty much all engines, the order of retrieval is undefined, like really undefined. As an example, the DBIx class test suite broke just this year twice in a row because the SQLite library changed the order it returns stuff in between versions. So I was expecting one thing, I got another thing. So at the end, I actually had to get my test suite to run stuff in deliberately random order to just make sure that my tests always pass. But if we want to make sure that we'll get our stuff in a specific order, we can order by criteria, just like with group by. So for example, we can get stuff like this. Order by experience. Unless specified, the order is ascending, like this. And you can say order by experience desk, which will make it descending, and it will turn the entire result set around. So what we learned so far, putting it all together. We have a selector, we have a source, we have a condition, we have a group or collapse criteria, and we have order criteria. And this gives us, yes, I know employees aren't supposed to be there. But yes, it gives us this. And yes, this is supposed to be max exp, and yeah, or let's see, maybe this is actually, hold on. Right, okay, so we're getting there. Sorry about that. So what we do here is first we execute the selector, the where selector. So we cut this and this and this away because those are larger than 9. Then what we do is we collapse the entire set by the department, and then out of the collapsed values, we choose the max experience. So in this case, it will be 6 and 8. So we get this. And this is actually our final selection. This is what it looks like. So we asked for department, and we asked for max exp, and we got it just the way we wanted. And it's returned in the right order. Now, this is how every select statement is actually evaluated. Like, this is the order in which things happen in your database. So first we get the source assembled, this one. Then we apply the horizontal filter to it. The horizontal filter means that we decide which rows horizontally match our condition and throw everything else away. Then we apply the group, a horizontal collapse. And then we apply an order, or it is undefined. Now, in a lot of cases, you will also see stuff like having, which is simply a post-collapse condition. So basically, after group by has been applied, after your set is already collapsed, you then have a post-collapse condition. So basically, whatever the values after the, for example, after the aggregates like max or count have been applied, we can apply a condition on them after the group by ran. And limit, it would make sense that somebody would want to limit a set. So for example, you have 1 million rows, you would want to get only the first 5 of them. There is no standard way to do this in SQL. There just isn't. For every engine, there is something that you need to do differently. And if we have time, we can get into this. But for now, there is a quiz. Here is our current data. If we execute this thing on top, what's it going to return? Yes, but more importantly, more specifically. Any takers?
7 times 42?
Exactly. It was 7 times 42. Whoops, sorry. Why? Because what happened is if we go back here, we got our source, which is our data. There is no horizontal filter. There is no group. There is no order. And then we applied our vertical filter to it. But our vertical filter in this case is simply don't select any columns at all, just get me 42 in every column. And that's why we got 7 times 42. And this is what it looks like. So this means that, damn it, this says expression. Sorry about that. It's obviously this thing on top, what can be really anything. And if we go further, we can test it. Can this really be anything? So we can, for example, get the department, get the count, which will be collapsed by the group by, and then we can just select the total count from the company and just see how many are there in the, in the table. And we're going to get something like this. Now, of course, this will actually not work. Even though the data completely makes sense to us, it will again not work because this thing is an actual value. The database does not know that the value is the same for each of them. And before the collapse, it will say, well, I don't know which one of those 7s you actually wanted. Even though all of them are 7, it will not know what to return. So it's the same issue like here. Basically, this is 7, 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 this is 7. But it does not know which 7 to return here, and which 7 to return here, and which 7 to return here, because as far as the database is concerned, they're different values. Right? So what we can do is we can just apply a max or a min, because we know that it's the same value everywhere, and this will actually run and return this thing. And we can, think about it a little more and go like, well, wait a second. If the selector can be anything, what about if we try everything? And in fact, any of those things can be another expression. This might be the one most important thing that you're going to get out of this talk, that this stuff is infinitely nestable. No matter how deep you go, it will do the right thing. And it might not be extremely performant if you go too deep, like 5 levels of inception or something like that. But it will return the correct data, the data that you expected. And let's get what we learned and apply it to do some insanity. So we not only want to see how many employees are in each department, we want to see how many different counts of employees are there in the company per department. So we have 2 departments with 2 employees and 1 department with 3 employees. So what we do is from this query, we get back 322. And then on top of that, we use this 322 as the source for the next query. And the next query collapses it to unique values of 3 and 2. Now, this seems kind of useless. Like it's not a very interesting thing to do. But Sorry about that. But what if we do this? Now, this looks like pretty crazy stuff, so let's walk through it line by line. So what we do here is, first of all, we do a simple select of the entire data set. No, nothing new here. And then we apply a weird filter to it, like where something is between 0 and 1. Now, what this something is, this something, before we apply the filter, we need to evaluate it, right? So what we do is we actually run this thing on every row individually. So we evaluate this thing for every row by itself, and then we return the result that we got. So what we have here, we have in here another count with the limitation to only count rows that are smaller in terms of lexicographic sorting than the rows from the same table. So basically, we have company and we have CNT. So we're looking at the same table from two different sides. So for example, for this one, what is going to happen, we have this ghost count that doesn't really exist anywhere. It's basically the CNT. It's this select count, which for this row will evaluate to 2. Because for this particular row, there are 2 employees which are before Java boss. If we sort this alphabetically, this will be on top, this will be on top, then this will be third, this will be fourth, fifth, sixth, seventh. So for this guy here, this particular count will evaluate to 2. For this guy, the count will evaluate to 3. And if we repeat this enough times, we'll end up with this. Now, what does this look like? This looks like an actual order in the table. So we can actually say, without sorting the actual set, we can say what comes after what based on an implicit sort by employee, which we just made right there. So now, if we apply this between 0 and 1, what we actually did is we select the first 2 items from the result set. And this entire thing now applies to the top of the set. So now from the big thing, we only select these 2 rows, and this is what we get. And because in the select we have everything that was declared on the table, which are those 3 fields, this guy will fall away because we never asked for it. And this will be the final result. Now, this thing that you just witnessed, so to speak, is the only limit, dialect, so to speak, that will work on any database. Now, this is excruciatingly slow because, I mean, you see the amount of acrobatics we have to do. But this is the only thing that will work on any database, and it's the only thing that Sybase understands. Sybase does not understand anything else. It's either this, or you simply ask for 1,000,000 rows, and you skip the first 900 if you want to start from, from a specific offset. All right. Any questions about this brain melt? Yes?
Why didn't we just put select all from company? What's the difference? Why do we have this inner select?
What do you mean exactly?
If we start from the beginning, select all from company.
Here, yes.
And so without this select all from company.
Because we need to evaluate the table twice, in a sense. We need to be able to look at a particular row. In its context, we need to look at the table as a whole again. And it needs a comparison between 2 different things, so it needs a different name. In order to give it a different name, I have to select again. See, here company is called CNT, here company does not have an alias. This will be clearer in a little bit, like in the next slide, I do this again with better naming and stuff like this. Any other questions? I guess we're good. Okay, moving on. We got that. Okay. So now comes the cool stuff, so to speak. For this part of the presentation, we're going to fire everybody from the company. We're just going to leave the Perl guys, and we're going to hire a rookie. And we're just going to have 3 rows in the table for the time being, and all of them Perl developers. Now, what if we execute this? It's the same kind of aliasing that we did in the, in the other example. So we ask for company twice, but we give it different names, which in this case basically kind of clones the table logically. So what we'll see if we run this will be this. It will take every single row and pair it, because we selected 2 things, and pair it with a row from the same table again. So for this tree, we have this tree. There is pairing like this. There is pairing. It's pretty clear what's going on. Now that's kind of not a very useful query. Like, why would we do something like this? However, what if we do this? We'll add a condition. So basically, this set, on top of that, we're going to evaluate it. So do not return me duplicates. Do not show me myself on my right side. And this is more useful because this is basically a list of coworkers for every developer in the company. And an interesting thing here is that just like in an Excel spreadsheet or in a CSV file, anytime that you want to represent information that has a part on the left side, which is one object, so to speak, and it has like several related things, you just repeat the stuff on the other side. And this is literally how the database communicates with you. So when you ask for something and you get stuff back, like for example, in row DBI or even DBIc, where you actually get objects that are correctly in a hierarchy and stuff like this, actually there is a process in the back of DBIc which collapses this stuff for you. So this is what the underlying stuff actually sees. Now, you might have noticed, you may not have noticed, when I was formatting all my queries so far, I was always indenting from. Like everything else was lined up correctly, nicely, but from was always to the side. Now, this was done because actually there is another syntax for this very same query. It's this. They're completely equivalent. So before that, we would say, get me a whole bunch of sources, and then apply a limit to them. And now I say, start from this source, and join this source to it with this condition applied. As far as result, those queries are completely identical. Logically, they're not. What happens here is we generate the source first, and then we apply the entire condition to it. Whereas here, we generate the source while applying the condition at the same time. Why this is important, this will become clear in just a second. Assume we want to get some more data out of this thing. So in our case, we say, we want not just the employee, but also their experience. And again, we don't want duplicates, so just coworkers. And by the way, interesting point, SQL suffers from the same problem like JSON. It cannot have a trailing comma in operators. If you have a comma right here, everything will die with a very, very unhelpful message pretty much on all databases. So watch for that. So we have this data set, right? And let's say that we want to find, like our developers don't have much to do. And for every developer, we will want to see if they have a rookie to train. So what we're going to do? We're going to add another condition. Get me the same set, but with the coworkers with experience 0. Now, here, we do it the old way. We generate the set first, and then we apply condition to it. So we have the set, and then we apply a condition. We get this row and this row, which is nice, but if for accounting purposes, for example, we wanted a list of employees and potentially somebody they could train, this would not work because this guy has nobody to train. He's thrown away. Nothing to select. So how do we get around that? We get around that with the syntax that we showed. However, we add a twist left. What left join means, literally, this is what happens in the database brain. First, it takes the first table, the left table, and freezes it in place, in a sense. Okay? So basically, I cannot really show it to you correctly because I would have to throw this away and just show you the data first, basically 10, 11, 0. But it knows about these 3 rows, and it keeps it in mind. What it does after that, it applies this condition from the on clause to the right side of the set. And then it goes like this. OK, let's see. This stuff is frozen. Let's see if any of them has a match. If they do, cool. This has a match, cool. If this doesn't have a match, we will still return them, but we'll return nulls on the right side. This is what left does for you. This is exactly how it works. And we got our data the way we wanted. And for example, if there were 2 rookies in the company, then we would get the Perl Lord twice with 2 rookies, and we get the Perl Guru twice with the same 2 Perl rookies. Now, what if we go back to the old company, good old days, and want to find in the entire data set the people with the largest experience for every department? But at the same time, we want to actually get the whole data back at the same time. Now, we could, of course, use group by and get their experience, but then we would not be able to get department and employee. We could do max on it and stuff like that, but it's just not something you really want to do because those aggregate functions are actually slow. They have to go through the data and evaluate stuff. So what I'm going to show you now is a very neat trick that does this in a very efficient manner, using only the tools that we have seen so far. So we're going to do this. We are going to start with ourselves, left join to ourselves under a different name. Sub means superior. And superiority will be determined this way. So anytime that you see somebody from my department who has more experience than me, put them on the right. If they're not, well, don't give me anything. When this is applied, when generating the actual source, before we apply where, before we apply the horizontal, the vertical selection, when this is evaluated, we already generate this set. So basically, for the Java boss, the most experienced in the Java world, we have nobody higher than him. For the next Java guy, we have 1 guy on top of him. For the next Java guy, we have 2 guys on top of him. This is the same data here. Left side, right side. For the net boss, it's, again, nobody above him, and it goes like this further down. Everybody following? All right? OK. So once this is generated, then we evaluate our where condition, our horizontal selection. And it will correctly pick out our top professionals in a specific department without any kind of group by, without anything. We just have them there. And then, because of our selector being explicit, and these guys never actually being mentioned there, they're thrown away. And we just get our original query plus anything that we would want to specify here. It can be another query. It can be anything you want. And we get exactly the data we asked for, much more efficiently, without having to collapse anything. We just We just got it. And the last thing that I want to show you today. Now, if you recall, I had this thing earlier, right? So when we do something like this, for every guy, there is a match on the other side. So this is multiplied by this, and this multiplied by this. And because we're actually using the same table, in our case, we have n times n minus 1 results. Now, if you had 100 employees, we're already in trouble, because this will return close to 10,000 results from database. And something, for example, like DBIx class, will have to merge through these 10,000 results, bring them back into 100 objects with 100 sub-objects each. And that's just not efficient. So what you normally want to do when you work with data like this, you want to be able to limit it, right? And let's say that we want to get the first 3 out of this result. Now, if we simply decide to limit this set, that's not going to work, because the limit works outside of everything. It works on the final thing. So if we get the first 3, we're going to get this, this, and this. This, this, and this. That's not what we ask for whatsoever. When we ask for the first 3, we ask for the first 3 employees from the main table. And then anything else that could have been matched to them. In this case, it's coworkers. So the first 3 employees and their coworkers. So how do we do that? Well, do you recall this abomination? It is a source. So all we can do is wrap another thing around it. So this is a source. We're going to get our employee and the coworkers from this source, which is already the first 3 the first 3 employees themselves. The only thing we had to change is we had to add an alias to this thing that is not really a table. It didn't exist before. So now it has a name. It's called C1. Here we also changed the C1 and the C in T stays. Between 0 and 2, the first 3. And then to this, we can join the other source, just like we did a little bit ago. And this thing will work. It will return exactly. Well, I didn't make a slide for this, but it will return exactly what you asked for, because we'll have our first 3 employees, and then what they join to is not important, because only those 3 will be multiplied. And your ORM or your script, whatever looks at this return data, will be able to compress it quickly, give it to you, render it in a page. You're done. And yeah, I guess that's pretty much it. How much time do I have?
7 minutes.
7 minutes. OK, excellent. Any questions? Yes?
Is there a reason that you use between instead of lower than?
No reason whatsoever. Just you could have totally used that's a reason. You could have used less or greater than. It would be absolutely the same result. Go ahead.
Yeah, I guess either you have to use 2 conditions, in which case you will have to duplicate something, right? Or alternatively, if you just use...
What do you mean 2 conditions?
I mean,
on his question? Or?
Yeah.
Okay.
If you need to emulate between,
yes.
then you will...
it will be where... Yeah, I would have to copy this twice. That's correct.
Exactly.
But really, the optimizer will take care of this. It will see it as the same thing, and internally it will compile it to the same. It will evaluate it once. For most databases, for example, for Oracle, most likely will not. Yes. Anyone else? Yes. I have some bonus slides if there are no more questions, so we can fill the time.
No, just I wanted to ask you about group by, why it's inefficient then.
Why it is inefficient? Because it normally has to build the entire set. Basically, from our point of view, it's pretty much the same thing. Like you look at you look at this and you know what it's going to do and things like that. But in terms of the internal work that the database will have to do, basically what happens is normally these things are very heavily indexed, okay? And when we're just generating a set before we applied any conditions to it or anything like this, the engine can cheat on a lot of things. It basically can optimize a lot of stuff away. With group by being further out in the chain of, in the chain of stuff that needs to be processed, the reification of the data is more complete. So what you get is basically more work for the same result. Does this sort of answer your question?
Yes.
Yes. Okay. Yes.
And what is the database you use for new projects?
I use MySQL by choice because it works, and I think PostgreSQL is kind of overhyped, for its actual feature set, but it also works. And ideally, I am a maintenance programmer, so I do not get to work on many new projects. I just work on what's already there. So. No more questions. How much time do we have?
I'm not sure.
Okay. All right. 4 minutes. We can quickly run through something very cool, I think. I mean, people like it when I show it. So we said that no database engine knows the same way to limit a set. And I showed you already the universal way to do it, right? I'm just going to quickly run you through what DBIx class has to do depending on the engine it works on, because we actually have full limit support on all the engines we support. Basically, if we cannot do limit on it, we just say we will not support it, right? And so far, there hasn't really been any. So let's start. Limit of set. Simple. So we basically have your select, group by, order by, so on, and then you have limit something, offset something. This is only supported by PostgreSQL and SQLite. Limit xy looks like this. About the same, but not the same, right? This is for MySQL and any SQL statement-based database driver. Row number over. This is the ANSI standard way of doing stuff. So obviously, Oracle supports it, DB2 supports it, Microsoft SQL Server 2005 or newer supports it, 2000 doesn't support it. Right? So what do we do here? They actually have a specific, this is a more generic function, but in this case what it does, it returns you a number with a specific order that you specify. You give it an alias, and then you do this between or greater or smaller, and that's how it works. But because this is an actual selection, this is not a hidden row like we were doing in the other case, we need to do another selection so we can throw this thing away, because the user never asked for it, so we're not going to return it. So this is how it actually looks. Skip first. Informix. Pretty simple, except everything is on the front. First skip. I'm not making this up. I'm not making this up. This is only supported by Informix. This is only supported by Firebird. They're not interchangeable. Row num. This is a good one. Now, this is for MySQL Corporate Edition. Depending on the result set attributes, it's either this or this or this. Now, why is that? And this is just amazing. We might get over by a minute, but I have to explain this because it's too good to be true. So basically what happens here is if we, let's see, if we do not have an offset at all, if we just have a limit, it's easy. There is an operator, row num, that does exactly this virtual numbering of your result. So basically 0, 1, 2, 3, and so on. So if we don't have an offset, it's easy. We just do this, and we're done. If there is an offset, however, it gets tricky because this thing is about 10 times faster than this thing. So here we call row num once, store it, do several selects, and then do the between and blah blah blah. Now, if we do things this way, it's fast, but we have to invoke row num twice. Why we cannot do this all the time? Because Oracle, in its infinite wisdom, will give you, if your order is not unique, if you have rows that can be either way, back and forth, the row num on both invocations in the same statement will return different random shit. So what you will get is you will basically have some numbers here, and you're going to limit them, and then some numbers here that will not match anything, and you'll get back garbage. So what we actually have to do in DBIc, we have to analyze our order by, see if it's unique, if it's, you know, if it's stable, and use this or this as one more minute, as, you know, as appropriate. And support by Oracle only, obviously. And we have two more interesting contenders. Now, I said on Microsoft SQL Server before 2005, we do not have the row number over support. So what we do, well, we only have top support. So we only can limit stuff from the top of the result set. Well, easy. We're going to select everything here. Then we're going to cut it on the top. Then we're going to flip it, cut more on the top. But because the user asked for a specific order, we're going to flip it again and return it. So there it is. So basically, order by reverse. So this thing will be ordered correctly. Then we order by reverse. Then we order correctly, and we return it. Now, of course, this has a particular problem. Because we have to revert the entire set if we have 5 rows. And we ask for offset 4 and 5 rows after that. What's going to happen is it's going to count to the end, revert it, count 5 rows, and return your 5 rows without any limiting. So it will actually return you incorrect results if you have an offset and you're asking for a number beyond the end of your result set. The same thing for fetch first, which is supported by DB2, like pretty ancient. It's absolutely the same thing, except there is no top, there is a fetch first that goes on the back of the query. And generic subquery, you already saw this abomination earlier. And yeah, that's it. And this stuff works, and you're using it every day. So enjoy. Thank you. Oh, yes. Yes.
Actually, it is now lunchtime.
Yes.
So if you'd like to speak over lunch with any other questions, that would be fantastic. Thank you very much for your
Thank you.
Great talk.